Hi guys! Welcome back to our discussion about the cross product of vectors. In today's discussion, we will focus on one of the applications of cross product of vectors, which is very important and useful in the field of engineering. This is about the determination of the shortest distance of a force or a vector from a point of known position. Kaya guys, muli ay samahan ninyo ako na discussin itong application ng cross product at sana ay huwag ninyong makalimutan na i-subscribe itong channel ko at i-click ang notification buttons so that you will always be notified of my next upload. Okay? So, here is the application of the cross product. We say that cross product can be used to determine the shortest distance between a force or a vector from a point of known position. So let us imagine that we have here the three mutually perpendicular axes with the intersection as the origin and this as the directions of the x, the y, and the z-axis. So let us distinguish the different planes such that we consider this as our xy plane, this as our xz plane, and this as our yz plane. And on the space, we imagine that there is a point A whose coordinate is given as x sub A, y sub A, z sub A. And there is another point B somewhere here whose coordinate is given as x sub B, y sub B, and z sub B. And from these 2 points, there is a vector f directed and the magnitude is given as f sub m. And let us imagine further that on this page there is another point C whose coordinate is given as x sub c, y sub c, and z sub c, such that the shortest distance between this point C and the vector f is shown by this line, where that distance is given as d. Now let us imagine that points A and B be located from point C, such that the position of point A and point B be established with reference point as C. And let us define that vectors as the position vectors RA and RB respectively. This is what we call the position vector RA, while this one shall be considered as the position vector RB. And the magnitudes of the position vectors RA and RB are actually the distance from C to A and C to B respectively, which can be denoted by R sub AM and R sub BM, or simply they can be called as the distance A or the distance B respectively. Now you will notice that after presenting the position vector, there are two triangles that are formed in the figure. One of the triangle is the triangle ACE as shown by this yellow colored triangle, and the other one is the triangle BCE as shown by this green colored triangle. Now considering triangle ACE, and if we will let the angle between AE and CA be called as theta, then let us try to imagine that that angle is theta with the opposite of that be D, while this distance shall be our RAM. And because this is a right triangle, the distance D can be computed using the functions of a right triangle such that the ratio of D to R sub A sub M is equal to sine of theta. This is the ratio of the opposite over the adjacent side of the right triangle. Now if we will cross multiply, then this becomes equal to RAM times sine of theta. Now, if the right-hand side of the equation shall be multiplied by the ratio of f sub m over f sub m, since this will be equal to 1, then nothing will change to this equation. So that the equations become d equals RAM sine of theta times the ratio of fm over fm. There seems nothing changed on this equation. But if we will be rearranging the numerator of the resulting equation, then the numerator can be rearranged such that this becomes this form. And this numerator is exactly the definition of the cross product of the position vector RA, this one, and the vector F, so that this can be transformed into the distance be equal to the cross product of RA cross F divided by F sub m. We consider this as the absolute value because we are talking of the distance between them. Because we could be getting a negative value if we will not take the absolute value. Now, what about if we consider the triangle BCE? BCE, this triangle. And the angle between BE and CB be called as beta. This angle shall be beta. Now let us try to isolate the triangle and redefine those angle as beta, this side as RBM, and the opposite of beta BD. And again, since this is a right triangle, then the distance B would, the distance D, which is the distance between the vector F and the point C, can be computed using the function of a right triangle, so that the ratio of D over RBM is equal to sine of beta. So again, if we will cross multiply the equation, then D representing the shortest distance becomes equal to the product of RBM times sine of theta. And again, if this equation shall be multiplied by the ratio of Fm over Fm, nothing will change to the right-hand side of the equation because the ratio of Fm over Fm is just equal to 1. And we know that anything multiplied by 1 will change or will remain the same. But after multiplying it by Fm over Fm and then rearranging the numerator, then the numerator becomes rearranged in this form, so that this form of the numerator is exactly the definition of the cross product of RB and F, so that the distance D now can be computed as the cross product RB cross F. And again, because this is a distance, we can take the absolute value of the cross product divided by F sub m. Now, after knowing the formula for finding the shortest distance, maybe we can make a generalization of how are we going to get the distance between a vector and a point of known position. So let us go back to the derived formula that D is equal to the absolute value of RA cross F divided by Fm, which is also equal to RB cross F divided by Fm. Again, in this equation, I'd like to give emphasis on RA and RB, because A and B are points along the direction of the vector F, whose magnitude is F sub m. Then RA and RB are the position vectors of these points, where the distance shall be computed. And in this case, it is the point C. Sabi nga, kung yung F ay dumaraan sa points A and B, then the position vectors shall be the position of those points from where the distance of the vector shall be measured, and that is at point C. So that if we will multiply that position vector by that vector F, then we can compute for the distance between the vector and the reference point C. So we can therefore make a generalization And how are we going to write the generalization? This can be said that the distance between a vector and a reference point, in our case, we will be calling it a C, is the cross product of the position vector from the reference point of any point along the direction of the force and the vector itself, divided by the magnitude of the vector. Sabi nga, yun daw distance between the vector and the point is equal to the cross product of the position vector of any point. It could be A or it could be B, where these points are the points where F is directed. The positions of those B or A from C will be called as the position vector. And if that position vector shall be multiplied using the cross product of F, and then the result is divided by the magnitude of this F, then we get the distance A between them. And so that actually is our generalization. And for us to be able to apply and to know how this could be used in solving problem, maybe it is good to consider solving a problem. So I prepared here a problem where this formula, where this distance can be computed. And let us have this problem. I have here a problem, a panel that is supported by a boom, and the boom is supported by a cable that runs from A towards C, another cable that runs from A towards B, and another cable that runs from D towards E. A force F runs along this direction AB. And in the question, we are asked to solve for the shortest distance between this point C and that of the force or the vector F. So sabi dyan, find the shortest distance between point C and the force F that transforms from A towards B as shown in the figure. So let us start by assigning the intersection of the X, Y, and Z axis as our origin, such that the coordinates of point A, point B, and point C should be taken, so that if we will be considering this as our origin, then point A would have a coordinate equal to 0, 0, and 5. 0 because it is lying on the x-axis, on the x-axis and on the y-axis, but measured 5 meters towards the direction of the positive z-axis. While point B would have a coordinate of 2, 3, and 0, and that of C would have a coordinate of negative 2, 3, and 0. The perpendicular distance from C will run in this direction, and this is what we are looking for. And this can be taken by the formula that distance D shall be equal to the cross product, either the cross product of RA cross F divided by F sub M, or RB cross F divided by F sub M. Whatever formula you may use will be the same, assuming that we will be taking this relationship, this formula, that formula will be used. Therefore, we have to consider taking or expressing the position vector of A, as well as expressing F in terms of the Cartesian vector. We don't have any problem about F sub M because it is already given in the problem. So how are we going to consider the position vector R sub A? So that R sub A is the position vector of A from C, and that can be taken as the difference in the coordinates of point A and that of point C, so that it will be equal to 0 minus negative 2, because we have here 0 minus negative 2, times I, time a plus 0 minus 3, representing the coordinate of this 0 and 3, as well as 5 minus 0 for K. So when we simplify, this becomes now the position vector of A from C, and that is equal to 2i minus 3j plus 5k. So after solving for the position vector, we now move to determination or to the expression of f as a Cartesian vector. So how are we going to do it? We know that f is expressed in terms of in Cartesian vector as the product of the magnitude multiplied by the direction of f. However, this direction of f is equal to the direction of the line AB because f is directed from point A to point B. And we know that the direction of the line AB shall be equal to the x-coordinate of x component of the distance between AAB plus the y component of the distance between the same point plus z component of the distance between the same point divided by the distance between A and B, so that this becomes equal to 2 minus 0 plus 3 minus 0 plus 0 minus 5 of k. So when this will be simplified, then we have the direction of A equal to 2i plus 3j minus 5k over the square root of 38. Therefore, if this will be substituted in the expression of f, f therefore can now be expressed as the 400 representing the magnitude times this direction, that is equal to 2i plus 3j minus 5k over the square root of 38. Now, if these two RA and F will now be substituted in the formula for D, as I have shown a while ago, then this becomes now our value as well as magnitude. And you will notice that F there will cancel each other. That is the reason why I have not simplified the equation, because while we go on with our computation, the magnitude of F will just cancel each other. And what will happen is that the value of D becomes equal to 2i minus 3j plus 5k cross 2i plus 3j minus 5k over the square root of 38. And this is now the cross product multiplication. So we apply now the third order determinant. Of course, we will be taking out first the constant, that is 1 over the square root of 38. And this becomes equal to the first element of the cross product shall become the first row of the determinant, while the second element of the cross product shall become the second row of the determinant. Then I, j, and k becomes the third row of the determinant. So instead of expanding it one by one, there is another way of simplifying this third order determinant without working much on the computation. And this can be done by extending the first two columns. These first two columns will just be extended to the right, so that this becomes now written as this one. So what you will notice that this is actually the first column, while this one is the second column. And to compute for I, the coefficient of I, we simply consider these two elements, that shaded portion, that is this yellow shaded element. While for j, this can be the product of this will be the for j, and for k we can have these elements will be the coefficient of k. So that when we simplify, let's go back. When we simplify, this becomes 1 over 38 times the quantity. Arrows downward will be positive, therefore the product of -3 and -5 will be +15. And arrow upward shall be negative, therefore that is -15 multiplied by I. Similarly, for the second element, that is for j, we consider this part, so that when you go downward, this product shall be positive, and that is +10, while this product shall be negative, and that's -10 for j. And then finally for k, we have here this product. When we take this product, that is +6, while when we take this product, that is -6, and that is equal to k multiplied by k. Now when this will be simplified, what will happen now? when that is simplified, I will have, okay, 1 over the square root of 38 times 15 minus 15 is 0. 10 minus negative 10 is 20, while 6 minus 6, negative 6 is 12. And that is actually the distance. And you will notice that this part is still in the form of a vector. So how are we going to get the magnitude of the resulting vector? Now, if we will be getting the magnitude of this, then that becomes equal to, okay, the square root of 20 squared plus 12 squared divided by the square root of 38. And then finally, simplifying, you will get a value of 3.78. And what is this 3.78? This is this, okay, a shortest distance between the C and the vector F that runs from A to B. So that is okay, our solution discussion of the application of the cross product. Again, if you have some question about the topic, you may write your comment on the comment box. And if you have not subscribed yet, I am inviting you to subscribe to my channel so that on my next upload you will be notified. Once again, thank you for watching.